All right, we're gonna do another session. I have just some updates. I added some TensorBoard logging, so this is using TensorFlow's uh, monitoring framework, and I'm printing into the log some information. So this is I ran this yesterday. Was this yesterday? I can't remember. I was just I left the training bot, sorry, the learning script that I had written running for a few hours. Um, Actually, I can see exactly how many hours it was if I go to where. Okay, I'm gonna set this to wall clock time. Yeah, so from 3 p.m. I shuttered out around 11 p.m. And what we're plotting here is the reward value that the bot was receiving, and the bot was set up to play against a materialistic, a bot a the it was set to play as the white pieces against the black pieces, and the black pieces were just playing random moves that improve material. So whenever there's multiple moves that have the same material balance, it would choose randomly among them. And white was learning, uh, let's say, material balance plus sort of piece position, ideal piece positioning, and and you can see, okay, and then the reward value I was giving each bot was, just the white bot, is if it wins it gets 1,000 points. If it loses, it gets minus 1,000 points. If it's a draw, it gets 0 points, and then otherwise it gains material during the game, according to the how much material has changed between turns. So if you play a move and you capture a queen, you gain 9 points. If you lose your queen, you lose 9 points, right, etc. Um, so this is the curve of the averaged reward value, and eventually it sort of settled around like 600, 700, around almost 700. So on average, it was getting 700 reward, which meant that it was winning a lot of games, right? And if you actually, if I have the log, I think I have the log here. Oh, I should, yeah, okay, here. So you might be able to read this. It's kind of hard to see. So this is the log before I killed the job. The win-loss ratio was 21, and if we can I go all the way back? Let's see, how far back will this let me go? I don't know how long the buffer is. It's not very long. Okay, so when we started out, we were looking at ratios of like two, right? We were like in the last stream, we were running, and it started at, the ratio was kind of like, I think it crept up to one eventually, or I guess when I initialized both bots to the same weights, it would start at one, around one, and it would slowly reach two, and we were like, oh, it's working. But and the win rate was like something like zero point 0.2, like also zero point 0.2, like also a small number. And now the win rate is 0.61, which means it wins more often than any other outcome, right? More often than draws, which is that's a big deal because there's not much information that these bots are using right now. So it was cool that it was actually working. The downside is it took hours for this to happen, but the upside is that the algorithm seems to be working. I think if we're willing to let it, if I let like I was thinking today for this session, I was gonna give more information to the bot, and then let it run longer. But we might even see faster improvements if we have the right information available to the bot, because right now it just doesn't have, it really just doesn't have good information. Right? It just, all it gets is the material value and where the pieces are placed. So it doesn't know what pieces are under attack. It doesn't know, if there's a piece available for capturing. So that information, I feel like there must be a way to give that to the computer. Anyway, so I'm also plotting the individual weights for the particular pieces. So these were the first few bits of information that the bot was weighting, and so it's like these are the first few features. So if there's and this is in alphabetical order, which is kind of weird. So this is like how much checkmate was worth, mate was worth. Initially in the first few hours, it grew up to like being worth 400 points, and then it slowly shrank down. These points don't have any unit really. It's just I don't know, higher is bigger, right? The higher the value is, the more the computer will value it. And then knights initially became worth a lot, like 30, and then they went down. They went down toward, what's the value here? They went down. Wait, this was 30. Yeah, it went down to like 15, and then went back, and then it went up near the end. And if you correlate that with the winning rate, I guess, yeah, I guess when knights became worth a lot, it was when it really started to win a lot. But anyway, and then let's see, pawns. Similarly, they initially went up really high, and that's interesting. It's kind of like if you start with just random play, one way to quickly improve is to value your pawns. But then eventually, apparently, it devalued the pawns, and then it slowly increased the values again. It's not clear exactly if that's the right way to interpret this, because the piece location information was also being used to weight the pawns. So there's actually hidden information here that's not being shown. So we can't fully interpret this directly. Yeah, queens became worth a lot, and then slowly became worth less. But one nice thing is they settled around queens being worth around 100, and like compare that to like a knight is worth like 40, a little less than 40. Rook is worth 80. This is the reward value. Okay, and then these are the position tables, or the square tables, which is really cool. So the bishops kind of, I don't really know how to read this. There's nothing really informative there. We can scroll through different steps. So this was early on in learning. It was kind of random. I feel like bishops stayed kind of random. Knights are kind of interesting. It really liked knights here. Oh, this is upside down, by the way. This is where the white pieces start. It's because of the indexing of the matrix notation. Like the 0th row is up here, so like rank 1 is up here. So yeah, it really liked having knights kind of, I don't know if you can see it, the color's kind of dim, but it liked having knights in the center but up close toward the enemy pieces. This seems a little weird. I don't know that this is a good idea unless the pawns are gone, but I guess if you can find an outpost there, that's the best case scenario. Oh, I'm sorry, I'm looking at king. This makes even less sense. Okay, why would it want the king up here? I don't know. Weird stuff. Not sure how to read that. Okay, so yeah, knights. It liked it. Yeah, okay, it liked it kind of. They liked them kind of in the center, I suppose. Their starting squares are still lit up as well. Yeah, the pawns. This is interesting. It likes advancing center pawns. That's really good to see. This is what we want to see. I don't know what to make of these like fianchetto pawns being not valued in those on their original starting squares. I don't know. It could it have learned to fianchetto? I really doubt it. This bot is really not good. I'll play a game against it in a second, and you can see it just hangs pieces left and right. It's because it's trained to play against another bot that plays really terribly. It doesn't like moving the queen too much, but when it does, it really likes this square. This is the sort of like scholars may attempt. I don't know that it actually works, but anyway, rooks, it likes them. I don't know. I mean, it sort of makes sense that you want them shuffling around on the home the back rank. But anyway, I don't know how much we can interpret all that. Again, it's winning against this random bot, so that's good to see. So let's play against it. Let me turn it on. And let me just quickly show you, and then I'll then we'll get to the goals for today, which is to try to, like, right now the bot doesn't know about castling rights. It doesn't know about, well, it kind of does. It doesn't know. So it knows about castling rights in that it knows that those are legal moves when they're available, but it has no way of being able to look ahead to know that there's maybe castling available a couple moves later. It only knows that there's castling available right now, if possible. So I was going to play against it. Okay, make sure I don't do rated. Casual, yeah, it doesn't really matter. So yeah, so we'll see. Yeah, I mean, these moves won't make any. You'll see the moves don't make any sense. I mean, that's, I don't know, it kind of makes sense there, but not really. Yeah, see, that's not a great move, and I mean, we'll just stop this in a second because it's not. It's just like that made no sense. So it's just kind of playing these weird moves because those are the squares it learned that it won some games, but when it reached these squares, when it when it had pieces on those squares. Um, should I bother trying to win this game? I actually don't know how to do this. Okay, it blocked with a queen. Interesting strategy. Yeah, I mean, I'm not. Yeah, so anyway, anyway, this game's not that interesting, so I want to get to the coding. There's going to be a mate soon, though. Where's the mate? I'll just grab some material. Okay. Alright, so I'm just taking all the pieces. Okay. Alright. Oops. All right. So anyway, so it doesn't understand anything. Like it understands material value. But not even. But right, because it can't look ahead. It just like puts its pieces in danger easily. So there's like the easy way to do. Okay, so I can. There's a couple ways I can make this bot smarter. One is I can make it look ahead. So I can combine my previous bot with this one. That seems kind of like it's kind of obvious. I mean, I can do it. Um, I don't want to do that though. I want to be able to see what we can do. Sorry, I want to see what we can do with just a purely evaluation based bot where the evaluation is learned. And I mean, so again, the first thing I want to do is give it all the game information. So like, it doesn't know about casting rights or en passant squares. I don't think. Wait, okay. One of the things, yeah, en passant squares are actually fine. I don't think I feel like I need. I don't think I need to tell it about that because they're only available for that move for the for that one position right after the pawn makes a advances two squares. So like planning for castling rights. It's a bit mask of the rooks with castling rights to test for specific squares. Interesting. Okay, so I think probably let me do. So what do we have? We have a board object. So we wanted to say is that a okay? It's just an what do you call it? An attribute. And to test for a specific square, we do this. So we do and chess dot bit bbh1 chess dot bbh1 Okay, so what's the right way to do this? I think we want to do. Actually, I think we want to do this. Come for the bot versus. Are you saying that you want to watch playing the bot? The bot is so bad right now. It's I gotta give it some more information. Anyway, yeah, I'm trying to. My plan with this series is to just show the whole process of building the bot. So I'll play some games with it later. Okay. All right, so I want to do, let's say, what is the best way to do this? Yeah, the bird bot is the bot's account. You can play it when it's online. It's online now, I suppose. You'll beat it really easily. But yeah, it's not on. It's not always online. Okay, so again, I want to do this. I think if I do, I guess the things I care about are H1, H8. Wait, why am I doing H1 first? Okay, let's do an order. A1 chess.bb, let's do H1 cr chess.bb, A8 cr chess.bb, H8. All right, so those are the square the booleans I care about. So why don't we, let's call it castling castle. Let's just call it castling, and then we will append it at the end here. I think if I just stick it here, it might work. So now it has castling information. Again, I want to avoid giving it en passant information. What else do I need to give it? If this is just for the basic information available, I don't want to deal with repetition. I'll just leave that alone. If our opponents, if the bot's opponents intentionally like trick it into a draw, I'm okay with that for now. I want to now. Yeah, okay, so let's try this. So what I wanted to do is, like, this is the info. I think if this works, then I can just continue on. I'm gonna test it, and it's gonna make it even, make the bot even worse than it is, because I'm starting over. Actually, no, I won't start. I have to. Yeah, I have to start over. So the learn bot is now been reset. All of his memory has been wiped, and it did not like what I did because I think I have to reinitialize it. Okay, I think it's running now. I'm going to take this away. Let me just leave it there. Comment it out. Okay. So, all right. So it crashed. So it doesn't like this. It can't reshape size of array 388 into size 64. Oh, I know. It's because I hard coded some stuff here. So now I want it to be 11, I think. think that's correct. Let's see if 7 shows up anywhere else. So there's 7 features, but now every time I have 7 features to describe the different types of pieces, and then I have and checkmate, and then I have one more, and then 4 more features to describe castling rights. Okay. Okay. Still complaining. So it's saying shapes 391 and 395 are not aligned. So for some reason I still have a old shape around. Why is that? What line is this? This is on descriptor. Let's see. So descriptor weights to descriptor. Which one's? Oh, is descriptor? That's weird. Yep. Just bear with me. Gotta do some debugging here. Why don't we do? I'll just do it in debug mode. Yeah. So while I debug this, this is just kind of brainless debugging. I just got to fix some indexing. The thing I was considering is, so eventually we're gonna make this a neural network, and what that means is we're gonna learn to process the raw inputs into something that is then processed into something else, which eventually leads to the scoring function. And what I would like to do as a sort of intermediate step is to do something called random projections, and that's this idea where we take the raw input and we actually generate a bunch of random ways to process the raw input, and then see if the computer can learn to use those random process values. And the idea behind that is it's a neural network tries to learn these projections essentially, and instead of we just make them random, sometimes they work almost as well. But we'll see. So let's see. I don't board. I have descriptor. Descriptor is size 395, and then I have a set of weights that are, as I said, is 391. So yeah. So weights is the one that's too small. So why is weights small? So, like, I want this to happen. Let me just print this. Is that happening? Oops, I did not do that. Yeah, initializing the weights. So now the question is it getting the right size out of this? Descriptor is 395, so okay. Now here we have weights are 391. What happened? Oh, I know. Is this the other player? No, this is the white player. Oh, okay, let me just try this again. Make sure we are initializing. I think it's working now. Okay, so it's running. Except something is definitely wrong. It's printing a gigantic number for the pawn score. How did that happen? Interesting. I suspect the numbers that I put into the castling rights are not what I thought they were. I thought they would be zeros or ones, but I think they're actually some kind of numerical values. Let's look at what those are. think I'm misusing this bit comparison. Okay, so CR is this giant number. Okay, that's not what I wanted. Oh no, that's fine. And then castling is not. Okay, so castling, I'm misusing this bit comparison. Okay, so how are they suggesting we do it? Oh, I set it to a bool. Okay. I guess it's just going to be 0 if it's... Alright, let's try it. Let's just say... Let me clean this up. So it's going to be bool. And let's say square or square in... Alright, so I'm making this a Python list comprehension. I think I did this last stream as well. It's 1, 2, 3, 4. Okay. And if I debug again, see if we get the numbers we want. So we should get true everywhere. Yeah, true, 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 true. Good. And I guess we don't know if it's gonna ever get false. I guess we can just hope it gets false at some point. I mean, logically it should, but there's always typos and bugs that can come up. But I think it should work. All right, let's try running it. See if it learns. So this will be nothing much has changed. Possible it might be a little bit slower than I remember. I'm not sure. What did I change? I think I just changed this castling rate stuff. Is that expensive? It's possible castling rates is expensive. Maybe it has to remember the whole history of all the moves. It shouldn't be that expensive. Oh, you know what? I didn't realize there's this. Has castling rates. Is this easier? Maybe I should have done that instead. Has castling rights. Checks if the given side has castling rights. Has king side. H has queen side. Maybe that would be cleaner. All this bit stuff is kind of ugly. I doubt it's making it that much slower though. I'm just gonna redo this completely. Okay, so we're going to do board has... Is this in board? I think it's in board. Why isn't it... okay. And we're going to do chess dot white. Okay. And we just change it to has queen side, and black. Okay, that's a bit cleaner. Oh, this piece grid should be back here. I don't know why. Okay. All right, let's run it and see if it still runs it, and if it's any faster. That would be nice, but I wrote queen's side. Oops. All right, so let's think about random projections. So the way to do this is to essentially take this vector and multiply it by a random matrix and then threshold it. let's call it X, and oh, you know what? I can open the tensor board and look at what's happening. So one of the nice things about tensor board is that it just like every single run. Okay, there's all these runs now, and a bunch of them are junk. So I have to find which one I actually want. It's not letting me scroll. It's annoying. How do I read this? 16 137. I think it's, what did I set it to? Wait, let me just do that so it's not, so it doesn't crash. I set it to this for this thing. So this is hour, minute, second. So I guess we look at, oh right, okay, so it's military time. So 1600. So the most recent run is this one. So let's look at that, and we can turn off the rest, I guess, and reload. We don't have any numbers yet. That's the 14th, so that was yesterday. Why is it not letting me? Okay, I'm just gonna hack this a little bit. The one other thing I can just quickly do is, oh shoot. All right, well I can see it here. So here I have no numbers. I don't know why. Is this really the correct run? Oh, here's reward. All right, so the reward value is like this. We've seen about 100 games, and it's getting kind of stuck at 300 something. Compare that to, you know, the other run I had. Oh, you know what? Am I on wall clock? No. Oh, you can't even see because the other one I ran for hours. But that reached like a reward value of 600. This one is, let me turn off the long run again. Yeah, this one is reaching 300 something. So that's a pretty fast gain. But we do know that if you leave it on for hours, it gains quite a bit more. You know, there was some fluctuation at the very beginning, but that was just because it randomly won a game. But you know, it's already better than the black bot. So yeah, win-loss ratio is 4.5. That's pretty good. Like I said, or like I saw earlier on, when we ran for hours, it got to 22. So it definitely gets a lot better if we let it learn longer. Okay, so this is fine. All I did was add castling. That's probably not going to make a difference. This is not happy. Why is this not happy? Oh, is it because this is static? I'm going to make this not static and give this a self. That should be fine. Okay, so now we're going to do some random projections, and to do that, I'm going to give a I guess one of the things is we have to save the projection matrix. Like all the different projections we do have to be saved. So if I let it be, I need to save it to disk. And it'll be kind of big. So we're looking at 300 features, I believe. I think we were looking at 395 features, and we need 395 times the number of like projections we want to do. And I think it would be reasonable to do something maybe just doing a square would be like reasonable. It's like 395 by 395. I mean, sometimes it's nice to give a nice round number there, but there's no reason for it. It's just arbitrary. So why don't we do... Yeah, but still, my point is I have to save it somewhere. I wish there was like a... You know, if I could just like save the random seed to generate. Can I generate a random matrix from a seed? It's a little bit of a hack. But maybe I can still do it. Maybe I can still do it. So we get random... Thanks for following, Musasi. Okay, so I could create a random state. And then... Yeah, I'm thinking if I create a random state and then generate from there, I'm just trying to be lazy so not have to like save a whole matrix to a file. All right, I'm just gonna call it 0, and then let's just generate the projection matrix. So we have weights. It's gonna be the same size as weights, and we're just gonna make it square. So like the you know the non-seeded way to do this, so it would be self that projection equals np.random.rand, and we're going to do just random Gaussian numbers. It'll be self.weights.size, self.weights.size. I think that's correct. So then we get a square matrix that comes out. That's great. That's great. Yeah, there's a lot of stuff here that I think only just I'm not spending the time to like really teach it. I'm just sort of trying it on my own. But from time to time I'll give pointers to what you might be able to study up on these things. So right now I'm just still trying to figure out how to fake a neural network, like, without doing the real neural network stuff, which we will do. I will get to that, but I want to do the easy one right now. Yeah, I mean, so I just want to, okay, does this accept a seed? No, it doesn't accept. So does it get a random state maybe? Let's see. No, I gotta figure out how to use this. So this method is called when random state is initialized. It can be called again to reseed the generator for detailed C random state. A random state exposes those methods. So can I from here get random? So I can generate a random state. So that's helpful. So here's what I'm going to do. I'm going to say, let's call it random state equals np.random.random state, and we'll give it the seed, which I'd called projection seed. Okay, and then from here we're going to not call it from np.random, but we're going to call it from random state. So now this should be like if we just save that seed, we'll always use the same one. Just, you know, so we can test this. So I'm going to print the first row of this. So the first row will be self.projection. Is that what we called it? First row will be 0, like that. So if I run this program twice, we should get the same projection, or that same row should print out. That's really big. Okay, so it's like 1.76, 4.4. Let's try it again. 1.76 was 0.4, and so on. Yeah, good. Okay, so we're getting the same matrix. So it's a big matrix, but what it's going to do is it's going to double essentially the features we have. But now instead of just having the raw features that we designed, we're going to I'm going to concatenate some stuff. So it'll be like this. So I will say projections equals self.projection. Sorry about the naming. Dot x direction. Let's check if that direction's right. So it's a matrix times a vector. I think that should be right. And then we want to threshold it. So if it's greater than 0, and that creates a set of new features that the AI can then use. So let's call this np.concatenate x and projections. All right, this might work. I don't know. So let's see. So what's happening is each of these learning engine has no attribute projection. Self.projection. So it's in the constructor. Self.projection. Learning engine object has no attribute. That's weird. How is this? Self.projection. I mean, is this line not running? Let's see. So yeah, so what I was going to say is that what each of essentially these projections, what's happening is each of these. Oh shoot! Of course. Okay. I have this circular logic going on. Sorry, I meant to just explain something, but then I realized it's wrong. So I'm calling this, but to call this, sorry, I'm calling this to figure out how many features there are. So I actually had to do this at the top, which is fine because I'm okay with that. So we're gonna do it here, and now it has no object weights. Okay, so I need to generate weights. Interesting. Which direction do I need to do this? So first I had to figure out how many features there are total, and that was like 395. But I don't want to hard code that because I want to be able to add more features later or remove features. Maybe I need to remove some features because there's some redundancy, right? Counting the nights and then counting where all the nights are, that's redundant. So technically I could remove something in there. I'm also counting nights for the current player as +1 and -1 for the other player, but we might want to separate those. So there's different ways you can represent all the information on the board, and so I want to be flexible in changing that. So I don't want to hard code the number of features, but then at the same time, when I calculate the features, I'm using the calculation of the features to figure out how big my random projection matrix should be. And this random projection matrix will affect how big the weights should be. So how do I do this? Um, all right, I'm just gonna hard code it for now, and we'll figure out how to fix it later. So it should be 395. All right, so to do, we'll make it more flexible, but for now, it'll be fine. Okay, and different bug. So only integer scalar arrays can be converted into scalar index. Ah, right. I always forget. Concatenate takes in a collection of things. Right. This thing is the input to concatenate. Okay, so now this thing was to print. I guess I just want it to be no, that's not right. Okay, I think I got it, but we'll see. Okay, so let me think. So what's happening is each of these projections is going to randomly mix up some of the original inputs, and the hope is that one of these random mix-ups will be one or more of the random mix-up will be a useful concept, like like a diagonal being under attack or being controlled by a piece. But we don't know what it will do, and yeah, we'll see if we can get to an even higher win rate. It may turn out we don't get to a higher win rate. We might get to a lower, or it might be even worse than before. But let's look at, maybe we can watch it from TensorBoard. So I guess we want to look at this one. Why is this one grayed out? Oh, it just, the color is gray. That's really, that, how do I toggle all runs? Toggle all runs. Can I turn it off? I'll just reload it. Toggle all runs and just turn on this one. And do we have a reward value? Okay, it got worse. The reward got worse, but maybe that's just the initial fluctuation, right? The early games are not really indicative of anything. So maybe it's slowly climbing, or maybe it's just failing. It could be either. It's hard to tell. I'm going to leave this on auto reload every 10 seconds. 15 is minimum. Okay, 15 sounds good. And okay, there might be a climb there. So, and then if we can look at this win-loss ratio, which I'm not printing to TensorBoard, which I totally could. Yeah, once it's stabilized, it's been around 2, but let's see if it gets any higher. So it might turn out that now there's just too many features for it to learn, and so it might take a while for it to actually make progress. Or it might turn out something could be wrong with what I did, and it just doesn't work at all. It's hard to tell. I mean, the fact that it's won 15 times and lost 6 times probably means it's learning, because it's initialized to be just like the black engine, but and then if I have the script running correctly, let's see, this is yeah, this so my bot, as it's loaded on Lichess right now, should be playing with the latest the latest weights. So just okay. So while I guess I'm gonna be right back. I have to take a phone call. I'll be right back. We can check. I can check on the progress, or you can watch the progress while I wait. Okay, so not much progress, right? So we're looking at this. This doesn't look like it's gone up much, and I guess we can examine some of these other numbers. Let me stretch this out a bit more. Is this really okay? So like mate increased in value. That's not to be surprised. Not too surprising. Knight slightly fluctuated, I guess. This is how much just the base count of each piece is. So I slightly preferred a higher score for pawn. Queen slightly increased. I mean, none of this is that different from the other runs. So probably it didn't do anything too get fancy. It's one of the downsides is this. I had these nice pictures we could look at. This interface is totally messed up with all the different runs. I can look at the images maybe, and then. All right, so I'll have to explain this a little bit. This is TensorFlow or TensorBoard is trying to like smooth this image, but this is a 8x8 chess grid. So what you're looking at is weights for. That's surprising. I'm surprised that they're down here. I thought that they were going to be up here. I think earlier I said that they were, and these look kind of like they're on the bottom as well. Did I flip it for? Let me check my code for flipping. But yeah, so those were the square tables. So it's showing which tables are good for each piece. But I'm just a little surprised that that it flipped it the way we normally look at a chessboard. Because I thought that it was gonna flip it only for black, but maybe I wrote it by accident to flip it for white, which is actually better for that visualization. So that would be here. Flip. If it's black's turn. If it's black's turn, we flip the board. Oh, okay, that's interesting. Yeah, I accidentally did flip it for white. So okay, this says if the the current board is black's turn, then it flips it around. But that's because when it's white's turn to play, which is our bot is our bot is training to be white. It's considering moves after it makes moves. It's considering the board position after it makes a move, which means it'll be black's turn. But a question from Musashi Vibes: do you play much chess? I play quite a bit online. I actually just wanted to. I started to look into how to do over the board chess because I wanted to try some of that, but I've never done that other than just like with my friends in like college and stuff. Um, but uh, but yeah, especially in the past few years, I kind of started doing online chess before the pandemic boom. But just like everybody else during the pandemic boom, I was quite online a lot, or online quite a lot. But anyway, so this is okay. That's interesting. So this is the pawn positions that it likes, and again, this is like an 8x8 grid that's been smoothed over. So it's seeing like the center of control as like a potentially good thing. Um, I it's not getting like the win rate's quite bad. I don't. So it's like learning something, but it's not converting that into actually winning against this bad bot. Um, I wonder. I wonder what's going on. It's just might not be working, but let's see. Let's look at the reward value. See if that's still. Oh shoot! This tab just does not work right now. So the reward value, yeah, it's just flat. It's not really learning anything. So I wonder if we let it run longer, will it get better? I mean, it's like it looks like it's getting worse and worse. So could I have introduced a bug that caused it to play even worse? What could I have done that did that? I mean, I added the castling rights thing. I added the color flipping, but I had that already previously, and I think it was working fine. Yeah, this is now even lower. Win rates lower. Hmm. Let's see. Other signs we look for. I've been other things I know is a good sign is if the queen value is high. Queen value is high usually is a good sign that it's learning the correct direction. Or if it if it devalues the queen, then it probably is learning the wrong thing. So is this high? It's like it started at 9. I initialized it to the standard values. It's now at around 11. Compare that to say the rook value. So the rook value is yeah, wait, what? Yeah, rook well, that's it's not a fair comparison because they both started at different points. Um, but at least rook hasn't overtaken queen or knight hasn't. Let's see, knight is hovering around 3 still. Bishop is around 5 now. Yeah, I mean, hard to say. It's still the rate is still getting worse. So I don't know whether it's you might be because it's overfitting. Like so, it has too much. Is so in machine learning and artificial intelligence methods, one of the things that can happen is if the bot tries to like too specifically learn the concept it's trying to learn, it'll it won't know what to do when it sees something that's slightly different. So if it's very specifically learning how to win one particular game that it played, it won't realize that like another position that's similar to a position that it saw in the other game, might lead to the same strategy. But because it's like, too similar, or sorry, because it's even though it's similar, it's not exactly the same, and so if it's only memorized the previous game, it won't know how to win the next one. That could be an explanation for this, but I don't know. This is consistently getting worse. And I feel like the reward value is consistently getting worse. So I kind of think that something's just completely wrong here. Let's see. Like this number is the real. Oh, well, okay. You know what? One of the things that this reward I'm printing is not precisely the reward we care about. Right? This is the reward at the end of the game. So this is just the win, loss, draw reward. Um, there's also rewards given to the bot as it makes captures during the game, and I'm not recording that. That's not saved anywhere. Um, so it's possible that those are going up, and this is just one bit that's kind of hovering and kind of it's going down a little bit, but maybe you could say it's staying flat while the other parts are going up. So it's possible that eventually, I mean, here we go. Like now, it went from 1 point something to 2 point something. So psychologically, it looks like it went up a lot, but it's slightly improved a little bit. So it's possible it might recover. No, now it's back down to 1.8 down there. Yeah, so that's yeah. I guess it lost a couple games in a row. Yeah, it'll be interesting to see. I mean, the other one took hours for it to reach its like kind of peak of ability, and this because it has more features, it might take might yeah it might take longer. Um, so we might not get to see like the results from in this stream because I do have to eventually stop, or not eventually, soon I have to stop. Let's do a rematch and see what happens. Um, See what kind of moves this bot is making. So we can play. Yeah, okay. I always want to do casual against my own bot. I made the mistake of playing rated games against this bot a couple streams ago, and I I realized I artificially inflated my rating like 10 points. Then I got rid of it. Sorry. Then I played against the bot against and forfeited twice to undo what I did. All right. So yeah, casual. So it's playing as black, which is a little funny because we'll see if it's. I mean, we don't actually know what. I mean, that's a decent move. But yeah, I was about to say we'll see it. Play some not great stuff quickly. I mean, yeah, it's okay. So it's um yeah. The thing is, oh shoot, I wasn't paying attention. Okay, well, I was about to say it's just learning chess, right? It's like played its first like 100 games of chess ever, um, and then I hung my queen. So, well, okay, well, let's continue. If it's as bad as it was, yes. If it's as bad as it was, then I'll be to recover and win this game still. Not because I'm good, because the bot is bad. Let's take the free pawn. Take the free queen. Yeah, see, this is all right. So let me see. So I mean, we're gonna win this game, but yeah, the win rate still hasn't gotten much higher. Um, that reward value. Let's look at the reward value. I can see maybe you can argue that's climbing a little bit. Um, it's around 100. Let's see if we can get higher. I mean, and again, you can ignore this stuff at the beginning. That's just like a few random games it won or lost or whatever. It doesn't really matter what happens in the first few. There's not enough to average over at that point. All right, let's just win this game. I mean, I could just forfeit the game. Not because I'm going to lose, but because it's it's what? Oh, okay. I'm just playing bullet speed, and I'm really bad at bullet, but I should still be able to beat this bot at this speed. Or will I? I actually don't know. No, okay. I just lost my knight. Yes, I can defend it. Well, that's not good. Okay. Okay, yeah, I need to pay better attention. Um, will it see the discovered attack? No, it didn't. care about it. Okay, finally. All right, so let's look at the score. It didn't really climb much. Oh wait, yeah, it's climbing. Okay, so this might be learning. This might be learning. Yeah, 2.21. It's possible. But you know, it's not. That's not an impressive score, right? That's playing against a really terrible bot. The black bot, the default one, is very bad, like much worse than it is now. But I guess so with these reinforcement learning bots, there's always this strategy of like self training. Not sorry, I shouldn't say they're always. It's the recent ones that have been really strong use this self training idea where it trains against itself or it trains against like a slightly older version of itself. And right now we're training it against like its most simple version. And if it starts to completely outplay that bot, then we can start to think about how to improve on that, or how to give it a more challenging opponent to train against. Right now it's training against this random bot, and again, previously, given just the piece locations, it was only able to reach kind of like winning. It was 0.6 of the time it would win. So, and I think it was like it would lose very rarely. So almost the rest of the time it would draw. Looks like there's a downturn here. I think we're losing some momentum. It's hard to say what's going to happen here. I can probably just leave this running. Yeah, it's slow. There's room to optimize this for sure. You know, I'm gonna do something. Where did I put that part about initializing it? Oh, it's in the main function. Next time I run this, I will make sure not to initialize the weights. And this. Okay, so that way I'll be able to resume from where we are next time I run it. And that will be, we'll be able to see it if it's, I don't know, I wish it could run faster right now so we can see it gain, and get better. But unfortunately that's just, I didn't write super highly optimized code. I'm curious what the slowdown is. Like if it's the size of that matrix multiplication I was doing, that could be sped up by putting it on a GPU, graphics processing unit, but I don't really want to do that. That's like, takes a little bit more to do that. I mean, we could throw this up on like Google Collaboratory or something and use Google's hardware to do this. That's one option. But yeah, so it's slowly gaining. I suspect it's still probably really bad. The question will be, I guess we won't find out for a few hours if I just leave this running. The question is, will it ever reach a point where it's like actually understanding like piece activity and, you know, control of different squares, files, ranks, diagonals. It's kind of like what I'm doing with this random projection method. We'd have to get pretty lucky to have some of those projections have some sort of strategic value. But it's totally possible. I really don't have a good intuition on whether it'll work. And then the next phase is to, rather than just randomly initializing random projections, you make those also learnable, and then you have to do neural network training. We are technically doing neural network training, but it's like a simple neural network. But if we make it more complex, there's just a little bit more math, and so there's two options. Either I write some more complicated code. It's not that complicated, but it's a little bit harder of a homework problem. Or we just download a deep learning framework, which we already have anyway. I'm using TensorFlow for the TensorBoard integration. But we could just download or use one of those deep learning frameworks to build our neural networks. That's the direction we want to go eventually, because then we can just start like changing the structure of the neural network just by changing how we're building it, rather than having to, like, I don't know, rewrite the code each time we change anything. But yeah, this is definitely learning. I mean, this was 2.42, then it dropped down, but that could be just random. I mean, there's a lot of noise in this. Now it's 2.39. No, 2.36. It's bad. Yeah, but it's it's just the way it's going to be. Oh, can you see what turn the bot is losing on? I'm not storing that information, so I can't see it. So like the loop that I'm playing the game is here, is this loop. Whoops. So I just have this loop playing. So yeah, we don't know. Maybe it's like surviving longer, right? That's something we can't tell. We're just seeing, all we're seeing right now is whether it wins or loses. But the bot itself is getting rewarded for, taking more material, right? So like, let's say if it loses a game, like from a scholar's mate, versus it loses a game at the very end, because it gets trapped by a back rank mate after it like captured a bunch of the opponent's pieces. Where it captured a bunch of pieces is going to be valued as a better performance than if it just gets mated immediately. So the thing is, none of those are likely to happen because the opponent is so random. The opponent is right now is just not going to make those like smart moves. But yeah, there's a reward that's not being shown in any of my logs. Like any of this thing stuff being printed out, or in the TensorFlow, I'm not showing the overall reward that the AI is trying to optimize. Right? It's trying to get as much reward as possible, and that reward includes material gain in addition to winning and losing. And all I'm plotting is winning and losing. So it's getting 1,000 for winning, minus 1,000 for losing, and 0 for draws. And right now it's like, what is this? It says right here that the smooth value is 125. So it's like, I don't know, probably, what does that mean? It's like winning. Maybe it's winning. What would cause that value? If the average is around 100, it gets 1,000. Like maybe 1/10 of the time it wins and then it draws the rest of the time. I don't know. That's unlikely. It probably loses every now and then too. Yeah, this number is dropping again. So it's going through another phase where it's like the value is dropping, and we're not sure why. It'll just keep fluctuating. Yeah, we'll see. Well, okay, so I mean, now we can just stare at this for hours, but I think we're just really looking at hours before it makes any progress. I mean, how many games has it played so far? It says 600. It's played 600 games. The other run, that run I showed you at the very beginning. So this is the run from yesterday or 2 days ago. It played 100,000 games, and that's when it reached like a score of 600. So it's hard to even compare the two, right? Because if you zoom in, you can kind of see, right? You can see the gray line. TensorBoard unfortunately made our current run gray, which is like the worst color to look at. But it's just the tiniest sliver compared to the 100,000. So, and even this 100,000 games, it looks like it went up and then went back down and then went back up. So there's going to be some kind of that weird stuff happening as we train this bot. So I guess I'll just run it overnight and then maybe report the results in the next stream. Because I don't think, yeah, we're not going to see any results now. I was kind of hoping giving it new features it would make some like quick leap, but I don't think it's going to do that. Yeah, let's zoom this back in. Oops. Zoom. Yeah, we're now in like one of those we're in the other part of the roller coaster where we're dropping down, and then eventually we might go back up. I should probably fix it so I see the full reward, because maybe the full reward is always improving, right? Including material gains. Like maybe it's gaining material, but losing the game in the end. Actually, why don't we let me just quickly examine the other values. So again, we're looking at, shoot, is that ever going to go away? Okay, I'll reload it. Tensor board is so nice, but it's also quite finicky. All right, so bishops are now worth 5. Mate is worth 30. Knight's worth around 5. Pawns are also around 5. So every piece, including pawns, are worth about the same. Queens are worth like 15. And these are another sign of that it's like actually a sign that progress is still to be made is that like the steepness of this curve is still quite high. In fact, there's some smoothing going on. If I turn down the smoothing, you can see it's just like climbing a lot. So it's going to keep climbing until it reaches a point where it feels satisfied, and then it'll smooth out. In fact, we can look at the run from yesterday. If you look at that, like it started to smooth out a little bit. It still wasn't done. I just stopped it because I needed my laptop for something else. Yeah, the queens went up. The queen value went up and then went back down. So all this stuff took quite a while for it to evolve. And then the other thing I wanted to look at is these images. So these are the square tables that it wants, where it wants the pieces. I'm not sure if there's anything we can read from here that makes any sense. You can kind of see hints of like lit up squares here. They're really hard to see in this view, but there's a little bit of light there. I like the pawns. I think that's always good just to know what makes a good pawn structure. So you're seeing that it likes to advance the center pawns. It's advancing the H pawn, but only one square. So it's not like full alpha 0. Alpha 0 would be 2 squares. But yeah, we'll see. And then for some reason it likes putting the queen up there. That doesn't make any sense. I mean, those could just be some random stuff that happened in one of the games that it saw, and it never saw it again, but because it saw it that one time, it thought that that's a good place to put the piece. And that's what happens when you get, I mean, chess, as everyone knows, is a complicated game, so there's a lot of kind of very specific stuff that happens that can't be summarized as general rules. So some of that might actually be good for machine learning to kind of just fall into that trap of being overly specific, but it might also hurt machine learning because it doesn't have anything to sort of generalize about. All right, it's starting to climb back up again. So maybe eventually it'll reach higher than, I mean, this is just a low value. I'll play one more game against it just to see what it's doing. It's probably doing the same stuff. Okay, casual. I'll play as black to make sure that it plays as white, because I'm a little skeptical about whether it knows how to play as black. Also, I'm not sure why it takes so long to make that first move. Yeah, so like pushing the center pawns, like it learned that from, I didn't tell it to do that, and it actually learned to do that, which is that's promising. I don't actually know how to. Okay. That move made no sense. Well, aside from moving the knight back and forth, there haven't been major errors. I don't want it. There's the first major error. Let's just move the queen out then. See if I can threaten mate. Oh shoot, I thought that was mate. Backwards knight moved. Okay, well, so now I'm losing. Or am I losing? No, it lost its queen earlier too, so I'm not losing. That doesn't work. That's a pretty decent move. So I would say that it made that one queen, it blundered its queen, but otherwise it hasn't been playing that bad. And then I've been playing worse. I played really bad. Because again, I'm trying to play faster than I should. I don't know what to do now. Well, I was just talking about, I was just giving it a compliment, and I guess that's fine. Okay, let's see. So I'm gonna wrap up now. But so this is gonna take a while. I'll report in the next stream if there's any progress. And then probably next time we might look into actually making it a neural network. It's too bad every single time we do this, it's never gonna be like immediate results. Unless again I put it up on like a really hardcore compute machine, which maybe is something I would consider. Like running things on my laptop, it's going to take a while no matter what. I'll consider that. Okay, all right. Enjoy your evening. Thanks for watching. Yeah, it doesn't seem to be doing great. No, it'll take time. So again, as I said last time, this is the curve. It took many hours for it to reach this level. So the goal is to get it higher than that, and it might take that many hours to do that. All right, we'll see. All right, bye everyone.